What is up, guys? Now we'll be working on the final part, which is optimization. You guessed it, part 4. Okay, so this part will be involving cylinders, so will be more challenging on the first, and the example problem we'll be working together at says there's a soda can, which we'll be showing with a cylinder that has a volume of 14.5 inches cubed. So this is what is given to us. So now we have to come up with the formulas that we know that involve volumes. So to get that involve cylinders. So to get the volume of cylinder, the formula of that would be pi r squared times height. And the question is asking us what will be the height, what will be the radius, and what will be the total surface area. That will be needed to know what the next equation is, and the next equation will be surface area. So we know that the surface area, since to get the cylinder will look like this. It will have the circle and the triangle will be the surface area plus the 2. So first we need to figure out what the triangle will be. So for that we will get 2 pi RH, and to get the circles it will be 2 pi r squared. That is the area of the circle, but since there are 2 we have to multiply by 2. Okay, next is getting this equation into terms of height to plug into the second equation. So first we would do that by plugging in what we have into pi r squared times height, and sending this to the other side, leaving us with 14.5 over pi r squared. So once we have this equation, we will plug it in to the surface area equation, which is surface area is 2 pi r times 14.5 pi, over pi over r squared plus 2 pi r squared. Now we solve to get this a little bit smaller, and we know that the pi's will cancel out and the squared will cancel out, and that will cancel out, which leaves us with these two multiplying to 29. Oh god. That leaves us with 29 over r plus 2 pi r squared. So now we fix that to have the r on top, 29 to negative 1 plus 2 pi r squared, and that leads us to the next step, which is finding out the derivative. The derivative of this equation would be negative 29 over r squared plus 4 pi r. So now we want to figure out what r is. So what we would do, we'll equal that to 0. So negative 29 pi r squared plus 4 pi r. Move that to the other side. You have positive 29 pi r squared equals 4 pi r. You move this to the other side, multiplying, so you're left with 29 equals 4 pi r to the third, and you divide that by 4 pi now, and that leaves you with r cubed equals 29 over 4 pi, which simplifies to 1.32 inches. So that will be your radius. And now I will be clearing some of this so we can have space to get our height. Okay, so now that we have your radius, we can simply just plug in our plug this into the equation where we made this in terms of h, which was h equals 14.5 over pi r squared. So now we put h equals 14.5 over pi and then 1.32 squared, which gives you the answer of height being 2.65 inches. So that is your height. And finally, the final step will be figuring out your surface area, which includes plugging your height and your radius to your surface area equation. So we're going to clear up a bit of space. And here, get that space, and now leaves room to solve it. So surface area equals 2 pi, and that is 1.32 and 2.65 plus 2 pi 1.32 squared, which once plugged into the calculator or solved leave you to 32.93 inches squared. So there you have solved for your height, your radius, and your surface area. Thank you.